Season 2. Woot woot.
I'm here. I made it. I hope everything sounds good. I don't know why. That's the first thing I'm worried about. It's season 2, and we're doing it. I do need you to turn the volume down out there because I can hear myself a little bit. Yeah, I'm just gonna get started, I think, because it's been a while. I'm very excited. I do want to say, let me turn this down for myself. Do I sound good? Oh, that's okay. We're at 1080p, 60 frames per second. We've got new emotes. Hang on. Oh, that's not a new one. I'm going to do just the new ones. Hang on. Some have gotten updates. They're old emotes that got little refreshes. And then we also have follow emotes, which I'm so glad they updated that you can use follow emotes in other streams because I love all of them. They're so cute. And this, hang on. This one is so good. I love it so much. It's so cute. Let me think. We also have new stream music. Probably doesn't sound like it right now because I know this song. New sub badges, new sound commands. Hang on. Maybe they work. I haven't tested them.
Oh shit. Here we go again.
Okay, they sound good. I just need to test that one. Okay. Yeah, a lot of new stuff. We're gonna get going. Get into it. Right? Yup, here we go. Here we go again. I hope I sound good because it's just gonna be me reading into the new mic. Oh, that's other. I was like, there's other big things. What was it? The new mic, new camera. Love it. Okay. Introduction to IOStream. Kaut, Sin, and Endel. Airhammer, how you doing? I noticed you were streaming Animal Crossing. So cute. I love your island. It looks like most of it's a beach. I love that. I was like, oh my god, so tropical. All right. In this lesson, we'll talk more about STD Kaut, which we used in our Hello World program to output the text Hello World to the console. We'll also explore how to get input from the user, which we will use to make our programs more interactive. Ooh. The input-output library. The input-output library, IO. Oh my god. IOStream is input-output stream. Oh. Okay. It's part of the C++ standard library that deals with basic input and output. We'll use the functionality in this library to get input from the keyboard and output data to the console. The IO part of IOStream stands for input-output. To use the functionality defined within the IOStream library, we need to include the IOStream header at the top of any code file that uses the content defined in IOStream, like so. I need to reread that one. We need to include the IOStream header at the top of any code file. Right, so if you want to use it, you need to write it. You need to call it. Rest of code that uses IOStream functionality here. Okay, so you could have this like in the middle if the things you don't need from it are above it, right? STD Kaut. The IOStream library contains a few predefined variables for us to use. One of the most useful is STD Kaut, which allows us to send data to the console to be printed as text. Kaut stands for character output. As a reminder, here's our Hello World program. Let's copy this. Or should we type it? Oh, we should have done a typing stream. Hello? Not stream, but started the stream with typing, right? We can end the stream with a typing test. In this program, we have included IOStream so that we have access to STD Kaut. Inside our main function, we use STD Kaut along with the insertion operator. To send the text Hello World to the console to be printed. Okay. STD Kaut can not only print text, it can also print numbers. Ooh. This produces the result 4. Okay. Can also be used to print the value of variables. Oh, yes. Okay. So here we're saying X is 5. And here we're saying, please say what X is. And then it'll be like, it's 5. That's programming. To print more than one thing on the same line, the insertion operator can be used multiple times in a single statement to concatenate, link together. What? I don't know if I've ever heard that word. Concatenate. Link together multiple pieces of output. For example, hello world. This uses the what was it? What was the word? Insertion. This uses the insertion operator twice. First to output hello, then to output world. Thus, it prints hello world. It might be helpful to imagine the insertion operator and oh, wait, are they different? Uh-oh. Let me go back. Like, wait. They lost me. Oh, input and output. Oh my God. As a conveyor belt that moves data in the direction indicated. In this case, when the content is conveyed to std_count, it gets outputted. I love that. Oh my God. I actually really love that. Okay. That's output and this is input. Okay. This program prints x is equal to 5. So we've got x is 5. Please say that x is equal to, and then output also what x is, please. Okay. I feel like I want to like really, for syntax reasons, I want to look at this for a second. Okay. We discussed that the std prefix actually, what the std prefix actually does in lesson 2.9. Okay. Using std endl to output a new line. What would you expect this program to print? Hi. My name is Alex. You might be surprised at the result. Separate output statements don't result in separate lines of output on the console. I did not expect it to be separate lines. Mostly because, what was it? This one wasn't. Wait, maybe I'm wrong. There was one that was like separate lines and then it did them together. Maybe I'm wrong. Okay. I think I am wrong. If we want to print separate lines of output to the console, we need to tell the console to move the cursor to the next line. We can do that by outputting a new line. A new line is an OS-specific character or sequence of characters that moves the cursor to the start of the next line. One way to output a new line is to output std endl, which stands for end line. Okay. So you're ending the line, so it will create a new line because you've ended it. This prints, hi, my name is Alex. Tip, in the above program, the second std endl, like, can I say something besides std? Like, isn't technically necessary, since the program ends immediately afterward. However, it serves a few useful purposes. First, it helps indicate that the line of output is a complete thought, as opposed to partial output that is completed somewhere later in the code. In this sense, it functions similarly to using a period in standard English, right? I see. Second, it positions the cursor on the next line so that if we later add additional lines of output, like have it say bye, those lines will appear where we expect rather than appended to the prior line of output. Third, so basically it's like it keeps the code clean that like if later you add another, you don't even have to think about will it be on a new line. It will be. Third, after running an executable from the command line, some operating systems do not output a new line before showing the command prompt again. If our program does not end with the cursor on a new line, the command prompt may appear appended to prior line output rather than at the start of a new line as the user would expect. That's true. I get that. Like if I were to run like something in a command prompt and it's like the cursor's at the end, I would think it's like not done. Whereas if it's at the next new line, I know that it's finished and I can put in the next command, you know? Okay. Right? Best practice. Output a new line whenever a line of output is complete. Okay. STD count is buffered. Consider a roller coaster ride at your favorite amusement park. Passengers show up at some variable rate and get in line. We're playing Roller Coaster Tycoon. Periodically, a train arrives and boards passengers up to the maximum capacity of the train. When the train is full or when enough time has passed, the train departs with a batch of passengers and the ride commences. Any passengers unable to board the current train wait for the next one. This analogy is similar to how output sent to std count is typically processed in C++. Statements in our program request that output be sent to the console. However, that output is typically not sent to the console immediately. Instead, the requested output gets in line and is stored in a region of memory set aside to collect such requests, called a buffer. Periodically, the buffer is flushed, meaning all the data collected in the buffer is transferred to its destination, in this case, the console. Okay. It's like, it's explaining all this, but like, I'm assuming it's just like computers are so fast that it's like that buffer, we don't even notice it, kind of a thing, right? To use another analogy, flushing a buffer is kind of like flushing a toilet. All of your collected output is transferred to wherever it goes next. Ew. That's fun. That was the author's note. This also means that if your program crashes, aborts, or is paused for debugging purposes before the buffer is flushed, any output still waiting in the buffer will not be displayed. Okay. Oh. Key insight. The opposite of buffered output is unbuffered output. Whoa. With unbuffered output, each individual output request is sent directly to the output device. What? Each individual output request is sent directly to the output device. It doesn't buffer at all, just go. Writing data to a buffer is typically fast, whereas transferring a batch of data to an output device is comparatively slow. Buffering can significantly increase performance by batching multiple output requests together to minimize the number of times output has to be sent to the output device. Give me a minute. I read it so that you guys can hear it, and then I'm like, okay, I did not grasp that. Let me give me a second. Okay. So buffering like batches the output together so that it's like like flushing a toilet. Like here's the first batch and then the next batch and then the next. So like I guess oh, like so like unbuffered output is like pissing in the grass. Like what I'm not sure code wise like how to visualize it, you know? Using n-line versus, I think that's a new line, the /n, right? Using n-line is often inefficient as it actually does two jobs. It outputs a new line, moving the cursor to the next line of the console, and it flushes the buffer, which is slow. If we output multiple lines of text ending with n-line, we'll get multiple flushes, which is slow and probably unnecessary. Okay. When outputting text to the console, we typically don't need to explicitly flush the buffer ourselves. C++'s output system is designed to self-flush periodically. It's both simpler and more efficient to let it flush itself. I don't understand fully. Okay, we will someday. I'm like, I think I'll just keep reading and I'll get it. Okay. To output a new line without flushing the output buffer, we use /n inside either single or double quotes, which is a special symbol that the compiler interprets as a new line character. I knew it. New line moves the cursor to the next line of the console without causing a flush, so it'll typically perform better. New line is also more concise to type and can be embedded into existing double quoted text. So you would probably want to do like new line, new line, and then at the very end do the end line, right? You'd want to do the one flush at the end. Okay. What? It's fine. All right. I have the chair like as straight as possible to try to help with that. Okay. So this looks like character output. X is equal to X. What is X? 5. New line. Single quoted by itself, conventional. Output. Yep. Double quoted by itself, unconventional, but okay. If you wanna, it's fine. Oh, that's conventional. What? That's look really wrong. I was like, oh. And that's all, folks. Between double quotes in existing text, conventional. Why is this unconventional to wait? Yeah. Just you even said use double quotes. This feels more crazy. Inside the quotes, between double quotes and existing text. I guess I could see that being quicker, actually, because then I wouldn't have to bother with that. But then I could see needing that for if I was doing something like this where I'd have to end the quote anyways to inject whatever, insert, what was the word? I want to remember the vocabulary, you know. Hello? We're all the way at the beginning. Hello? Insertion. Insertion operator. Okay. This prints x is equal to 5. Yep, and that's all, folks. When a new line is not being embedded into an existing line of double-quoted text, it is conventionally single-quoted. Okay. I see. So it's exactly like what I was just saying, where I was like, I guess this is faster, but I would also need to do it like this if I had to do it like this. That would be the conventional way to do it. Okay. I get it now. I understand. For advanced readers, is that me? Are we advanced? I feel like I just want to read everything though. I will be advanced. I want to know what the advanced people are knowing. In C++, we will use single quotes to represent single characters, such as $a or $sign. And double quotes to represent text. Oh. That's so much easier to, like, we use single quotes for a single character, and then we use double quotes if it's more than one character. Okay? Even though new line is represented in source code as 2 symbols, it's treated by the compiler as a single line feed character with ASCII value 10. Ooh, because it's just enter. Yes. And thus is conventionally single quoted, unless embedded into existing double quoted text. We'll discuss this more in lesson 4.11, characters. When new line is output, the library doing the outputting is responsible for translating the single line feed character into the appropriate new line sequence for the given OS. See Wikipedia for more information on OS conventions for new lines. Okay, we'll go to Wikipedia. I'll stay here, it's fine. Author's note. Although unconventional, we believe it's fine to use or even prefer double-quoted new line in standard output statements. Well, why are you telling me it's unconventional? It's like, here's what people do, but I like it like this. This has 2 primary benefits. It's simpler to double quote. Is it? Oh, wait, is it? It's simpler to double quote all outputted text rather than having to determine what should be single, just have everything be double. That makes sense. More importantly, it helps avoid inadvertent multi-character literals. What? We covered multi-character literals and some of the unexpected output they can cause in lesson 4.11. Okay. Single quotes should be preferred in non-output cases. Why? We'll cover what new line is in more detail when we get to the lesson on characters. Okay. Best practice, prefer new line over end line when outputting text to the console. Warning, new line uses a backslash, as do all special characters in C++, not a forward slash. My Achilles heel. Backslash is above the enter. I don't know. It's not that I get them mixed up or like I have a hard time. It's more just like I see them and I always want to go for the forward slash because that's just the most common one that I use. And then I'm like, oh shit, it's facing the other way. Okay. Well, so we need to remember special characters all use slash, the special slash. Special characters use the special slash. Okay, using a forward slash or including other characters inside the single quotes, like a space or period, will result in unexpected behavior. Tell me what that is. For example, stdcout new line, with the forward slash, will often print as 12142, which probably isn't what you were expecting. That's really weird. I assume it's just a different ASCII, right? I don't know. Yeah. I think it's just more like HTTPS, like having to write that. I don't know. All right. Real quick, I got a new phone. She's a flip. And then he's like drinking tea. And he's so cute. I love him. Anyways. I just want to show it off. I love it. I got it like this weekend. Okay. Sin. Or sine, right? Sine, cosine, tangent, what? New phone, who dis? Hello. Okay. Is it, please, it's sine, right? I'm gonna say sin a bunch. Because I'm like, sin? Sine.
New
Wait.
phone, who dis?
But I feel like sine. Isn't that the one with the E at the end? No? Is another predefined variable in the IOStream library, whereas count prints data to the console using the insertion operator to provide the data. Sin, or character input, that's what it is. Okay, so I can say sin. Character input reads input from keyboard. We typically use the extraction operator. Insertion and extraction. Why do they say that though? It's like input, output, insertion, extraction. You could just call it the output operator or something, you know? To put the input data in a variable, which can then be used in subsequent statements. Okay. Enter a number. X has a blank. I'm like not reading the green part. I'm just trying to like read the code. The X is an empty variable, which means that it can be filled with information. And then the character input is asking for what X will be. And then the person will input something. And then character output is you entered the thing you said. A new line. Okay. Yeah, I do want to compile this actually. I'm like, is that... Wait, I have to compile it? Like... Oh wait, it runs it right here. I forgot. I always think about Java where it was like a whole separate thing and it was stressful. Right? Wait, is this... I'm confused. This is the debugger. Error list. F7, right? No, yeah, it does build right here. I thought so. Output. Okay. Well, wait. No, it's just built. How do I run it? When you run the program, line 5 will print enter a number. I don't know if they ever told me how to do this. I'm like, what? Maybe they had, actually. The beginning. In the beginning. Start window? No. How do I say to do it? Errors list, no errors. File. Project. Build solution. But I did. I feel like I can't move on until I figure this out, right? Build hello world. Compile. Control F7. What is the difference between compiling and building? All right, we're gonna have to hang on. No, not the index. One moment. Wait, compiling your first program. That's what I needed. Shit. Go back, go back. Got this. We're gonna figure it out. Okay. Interesting. To compile your program, either press F7. If this doesn't work, try Control Shift B, which was the other build option. Oh, it wasn't Control Shift B, it was Control B. Okay. Or go to the build menu, build solution. If all goes well, you should see the following appear in the output window. Okay. This means your compile was successful. To run your compile program, press Control F5. Or go to the debug menu and choose Start Without Debugging. Where is that? Debug menu. Debug. Start without debugging. Okay. Control F5. Enter a number. 5. No. 6. You entered 6. We did it. We figured it out. See? We just had to jump back for a second. And now we can move forward. I was like, he didn't show us. He did. He did. And I say he. I don't know. I just assume. Apologies if that's incorrect. I just have an image in my head of the person reading this, and it's a man. Not in any stereotypical way, just in like, that's the vibes I'm getting through the text, you know? That's who this is. I have to imagine someone there typing this and like thinking about how they want to teach this, you know? We did it. Wait. Okay, try compiling this yourself. For example, entering the value 4. This is an easy way to get keyboard input from the user, and we'll use it in many of our examples going forward. Note that you don't need to output new line when accepting a line of input, as the user will need to press the enter key to have their input accepted, and this will move the cursor to the next line of code. Because the enter key is the new line. If your screen closes immediately after entering number, whoa. No, it did not do that. If you're using CLion and you entered has a space before it, this is a huge bug in CLion. Okay. That's interesting. Why would there be a bug? Maybe there needs to like not be space like that. I don't know. Just like it is possible to output more than one bit of text in a single line, it is also possible to input more than one value on a single line. Okay. Output, enter two numbers separated by a space. And then we're saying X has an empty variable. And then we're saying Y has an empty variable. And then we're asking the user input X and also input Y. And then output that you entered whatever X was and whatever Y was. So the first thing the user types will be X. The next thing the user types will be Y. That feels very clean cut, clear. This produces the output. Enter two numbers, 5 and 6. You entered 5 and 6. That's so weird. Those were the numbers I was gonna do. 5 and then no, 6. Values entered should be separated by white space, spaces, tabs, or new lines. Okay. Key insight. There's some debate over whether it's necessary to initialize a variable immediately before you give it a user-provided value via another source. Since the user-provided value will just overwrite the initialization value, in line with our previous recommendation that variables should always be initialized, best practice is to initialize the variable first. What? I get it, but I'm just like, is that what we did here? Is this initializing it? This is initializing it, and if I put a 0 in there, then it would be assigning it, right? For advanced readers, the C++ IO library does not provide a way to accept keyboard inputs without the user having to press enter. Oh, I need to check real quick.
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
That's okay. Perfect. Like volume, unless you guys can't hear it very well, but like that sounded really good to me. Okay. C++ IO library does not provide a way to accept keyboard input without the user having to press enter. If this is something you desire, you'll have to use a third-party library. Wait. For console applications, we'd recommend PD Curses, FX2E, CPP Terminal, or Not Curses. Many graphical user interface libraries have their own functions to do this kind of thing. Okay. So basically they're saying, like, if you want the user to be able to hit 5 and then 6, and then right when they hit 6, it's done and like moves on. I mean, I don't know what I'm going to be writing, but it's like, I kind of like that the user can sit and hit enter, you know.
It is perfect.
Right? I loved it. Okay. Character input is buffered. In a prior section, we noted that outputting data is actually a two-stage process. The data from each output request is added to the end of an output buffer. Okay. Later, data from the front of the output buffer is flushed to the output device, the console. Right, like the roller coaster cart, right? Key insight. Adding data to the end of a buffer and removing it from the front of a buffer ensures data is processed in the same order in which it was added. This is sometimes called FIFO, first in, first out. I've heard that. FIFO sounds really cute though. Hey, FIFO. Okay. Adding data to the end of a buffer and removing it from the front of a buffer ensures data is processed in the same order it was added. Gotcha. You make sure everyone stays in line. The next person in the queue to go on the cart will be next. Right? Similarly, inputting data is also a two-stage process. The individual characters you enter as input are added to the end of an input buffer inside character input. The enter key pressed to submit the data is also stored as a new line character. The extraction operator removes characters from the front of the input buffer and converts them into a value that is assigned by a copy assignment. That was what I was talking about, assignment. Right? Where it's like, what was the word? Initialized? It's initialized when there isn't a value. And then when there is a value, then it's an assignment. Right? Converts them into a value that is assigned by a copy assignment to the associated variable. This variable can then be used in subsequent statements. Key insight. Each line of input data in the input buffer is terminated by a new line character. Give me a minute. So it's terminated. I think it's saying like the new line is doing the flush as well with the input. Right? We'll demonstrate this using the following program. Enter two numbers. Character output, enter two numbers. We've got an initialized variable x, character input for x, and then we have initialized variable for y, character input for y. And okay, so that was gonna ask it twice, like separately. So there'd be 2 new lines when they hit enter those 2 separate times. You entered X and Y. New line. This program inputs to 2 variables, this time as separate statements. We'll run this program twice. Run 1. When character input X is encountered, the program will wait for input. Yup. Enter the value 4. The input 4 new line goes into input buffer. And then, it's holding the 4 while it asks about the 5. And the value 4 is extracted to variable X. So it applies 4 to X. It's like holding it. And then is asking about Y. But wait. Input 4, new line, goes into the input buffer. And the value 4. So it's saying and, so both things are happening. Goes into the input buffer, and the value 4 is put into the variable, making it an assigned variable. When character input Y is encountered, the program will again wait for input. Enter the value 5. The input 5 new line goes in the input buffer, and the value 5 is extracted to variable Y. Finally, the program will print you entered 4 and 5. There should be nothing surprising about this run. When character input X is encountered, the program will wait for... run number 2. Program will wait for input. Enter 4 space 5. The input 4 space 5 new line goes into the input buffer, but only the 4 is extracted to variable X. Extraction stops at the space. Why? I guess we'll find out. Extraction stops at the space. When character input Y is encountered, the program will not wait for you to input. Instead, the 5 that is still in the input buffer is extracted to variable Y. The program then prints you entered 4 and 5. Whoa. Note that in run 2, the program didn't wait for the user to enter additional input when extracting a variable Y because there was already prior input from the input buffer that could be used. It throws... I see. It throws the whole thing into the input buffer, which is like the waiting room, I guess. And then it's like, okay, I got 4. All right, now I need Y. Okay, here's a Y, right? Pull it out of the waiting room. I see. Key insight. Character input is buffered because it allows us to separate the entering input from the extractive input. We can enter input once and then perform multiple extraction requests on it. I don't have water. I'll hydrate with this. I actually get a little scared with the 60 frames per second. I'm not used to like moving that fast in the camera, so I'm like, whoa. Okay. You can enter input once and then perform multiple extraction requests on the one input. Oh my gosh. Oh my gosh. Whoops. I don't know what I was thinking. Here we go. Oh my gosh, I can actually see a little better. Here we go. Here's a simplified view of how operator... Oh shit, that's the extraction. No. trying to remember. I'm trying to remember which one's input, which one's output. I know that that one's going this way, but I'm like, is that input? That's input. Works for input. Oh my gosh. Okay. We did it though. We figured it out. I'm just thinking like, I don't know. I'm trying to think. He said conveyor belt, but I'm thinking like, almost like overcooked. Like the window to like put the food out is like, it goes to the right. So that's out. And then input, you know? Anyways. If character input is not in a good state, the prior extraction failed. Oh, if it's not in a good state, like the prior extraction failed and character input has not yet been cleared, no extraction is attempted and the extraction process aborts immediately. Leading white space characters, spaces, tabs, and new lines at the front of the buffer are discarded from the input buffer. This will discard an unextracted new line character remaining from the prior line of input. If the input buffer is now empty operator input, or extraction insertion? The insertion operator. If the input buffer is now empty, operator insertion will wait for the user to enter more data. Any leading white space is discarded from the entered data. Did I just... Okay. Wait, I mixed up two lines, didn't I? I'm reading 3. If the input buffer is now empty, operator insertion will wait for the user to enter more data. Any leading white space is discarded from the entered data. Operator insertion then extracts as many consecutive characters as it can until it encounters either a new line character representing the end of the line of input or a character that is not valid for the variable being extracted to. The result of the extraction process is as follows. The extraction aborted in step 1, then no extracting attempt occurred. Nothing else happens. If characters were extracted in step 4 above, extraction is a success. The extracted characters are converted into a value that is then copy assigned to the variable. If no characters could be extracted in step 4 above, extraction has failed. The object being extracted to is copy assigned the value 0 as of C++11, and any future extractions will immediately fail until character input is cleared. Any non-extracted characters, including new lines, remain available for the next extraction attempt. Related content. We'll discuss how to detect and handle extraction failures. Handle extraneous input and clear character input in lesson 9.5. Oh man, we're still in chapter 1. We're gonna get this. Now I'm like, damn, how we gonna be at chapter 9? Like, there's gonna be like sissy stuff. Sissy. For example, given the following snippet. Here's what happens in 3 different input cases. So user types 5A and enter. 5A new line will be added to the buffer. 5 will be extracted, converted to an integer, and assigned to variable x. A new line will be left in the input buffer for the next extraction. The user types B and enters B new line. Enter B new line will be added to the buffer. Because B is not a valid integer, no characters can be extracted. So this is an extraction failure. Variable x will be set to 0, and future extractions will fail until the input stream is clear. If Character input is not in a good state due to prior failed extraction. Nothing happens here. The value of a variable x is not altered. We'll explore more cases in the quiz below. Quiz time. Not yet. Okay. The extraction versus insertion operator. Nuke programmers often mix up character input, character output, the insertion operator, and the extraction operator. Here's an easy way to remember. Character input and character output always go on the left-hand side of the operator. Okay. Character output is used to output a value. Character output. Character input is used to get an input value. Character input. Extraction, right? Extraction is used with character output and shows the direction that data is moving. Moves the value forward to the console. Okay. Insertion is used with character input and shows the direction the data is moving. Moves the value the user entered from the keyboard into variable X. Okay. We'll talk more about operators in lesson 1.9, Introductions to Literals and Operators. As an aside, if you're wondering why C++ uses character output and character input instead of something else, okay, read some Wikipedia article. Quiz time! Yay! Let's do it. Question number 1. Considering the following program that we used above. Ooh, this is like essay quiz. Enter a number you entered. Right. Program expects you to enter an integer value as the variable x that the user input will be put into this is an integer variable. What? Run this program multiple times and describe the output that results when you enter the following types of input. A letter such as H. If we put in 8, because I'm not going to put it in, I'm going to guess from what we just read, I'm going to guess the answer. If we put in H, it will fail because it's looking for an integer and it did not get an integer. So it will fail. The 0 also, because C++11, I guess puts in a 0. It's like that was not anything. 0 is always printed. What's happening? An integer can't hold a letter, so extraction completely fails. X is assigned the value 0. B, a number with a fractional, because integers are not fractionals, they're whole numbers. Try numbers with fractional parts, it would probably fail again as well because it's just not an integer and it wants one, right? Try numbers with fractional parts less than and greater than. I felt like it would give us a 0 as well, but what's happening here? Oh, wait. No, it would, hide it. I didn't read it. Hang on. It would pull the 3 and then it would hold the 0.2 in the buffer or something. I don't know what it does with it. I guess you need to flush it or something. I don't know. Yes. Okay. The fractional part is dropped, not rounded. What's happening? Given the number 3.2, the 3 gets extracted, but period is an invalid character, so the extraction stops here. The 0.2 remains for future extraction attempt. Yeah, it just gets like held. If you're wondering why this isn't a disallowed narrowing conversion, narrowing conversions are only disallowed during list initialization. My favorite word. Which happens on line 6. The extraction happens on line 7. What is line 6? This is list initialization. This has been initialized. Extraction is on line 7. we extract it from the user there. Okay. A small negative integer. Okay, that one would be 0. Right? Oh yeah. Do I have... Wow, I don't have anything with sunglasses. I maybe should have put sunglasses on Typees, but he's just too cute. Too good. Look him go. Oh, he's incredible. Anyways. Yeah, I feel that it will fail, or I don't think he said anything like this where it could maybe like put the negative into, like, will it, like, if you did like A, B, 3, would it just like ignore the A, B and then hold like, oh, there's the integer I was looking for at 3, right? Would it do that? Like, I'm saying like this might be 0, but it might also pull the 3 and then put that in the buffer, right? Result, the entered number is output. What? What's happening? A minus sign at the beginning of a number is acceptable, so it is extracted. The remaining numbers are extracted as well. What? I need that explained to me a bit more. I guess it was explained that a negative is acceptable for an integer. I guess it is an integer. I wasn't thinking. It wants an integer, and a negative integer is still an integer. Yeah, I guess I do maybe need a cool emote. I need more spots, more emote slots. I filled them up. Okay, so that makes sense now. That is not confusing anymore. It asked for an integer, it got an integer. Doy. A word such as hello. Okay, that would fail because it's still just letters and it doesn't want letters at all. 0. Can't hold a letter, so it's just very upset. A really big number, at least 3 billion. Whoa. 3 billion. It says enter a number, an integer. Do integers stop after 3 billion? Could ask Bezos. I feel like maybe like the memory, like it would maybe crash because it's like that's an upsetting thing to ask the program to do. Like, I don't know, like it can't buffer that big. You know what I mean? You are most likely to get the number that. What is happening? X can only hold numbers up
Any
to a certain
whole number
size.
and 0.
Excuse me. I tried to cough away, but oh my god, look at them go. Do I have? I'm pretty sure I do. No, I don't. I need Froggy Jam in the Better Twitch TV because that's what it's based on. I need to have it like. We have both. Uh-oh, I'm yawning. Uh-oh. It's only 10. Jeez. Okay. Can only hold numbers up to a certain size. If you enter a value larger than the largest number X can hold, it will be set to the largest number that X can hold, which is probably that. But it might be different on your system. We'll discuss this further. Interesting. Okay, well, what if I did that, right? And I just set the number to just like kind of bigger than that. Because we already have this where it's like enter a number. So what was it? Control F5? Enter a number. And then we'll add a 4. And then another 5 and a 6. No, wait. Yeah, whatever. Yeah. Okay. He's like, it's gonna most likely be that number. And he's like, yep. I couldn't do bigger than that. Okay. Exited with code 0. Okay. He was right. Most likely. And it was most likely. Okay. A small number followed by some letters. It will pull 123 and just screw, like, fuck those, right? The numeric values are printed 1, 2, 3. What's happening? Excuse me. Pardon? 1, 2, 3 is extracted. The remaining characters, ABC, are left for later extraction. So I could set it. Whoa. Lumia stream. I need to do some checks with that. I don't think it's meant to do it for what is it? It's like what are they called? Like shop redeems, or like, they're silly. What are they even called?
Looked like you were caught in a red alert.
It was
lol.
literally red alert. Red alert. Alerts. Twitch. I'll figure this out later, whatever. We'll just red alert it today. We got the shirt. Okay. A few letters followed by a small number. See, this is what I was asking about. Like, if you did A, B, C, 1, 2, 3, I think it'll just pull the 1, 2, 3, right? Or will it give me a 0? It might be like, bitch,
Represent.
no, and just stop. Because that's not, but it might also just keep looking until it finds what it wants. 0 is always printed. That is what I wanted to know. An integer can't hold a letter, so extraction completely fails. X is assigned the value of 0. Okay, because it's asking for an integer. Specifically because it's asking for an integer. It kind of feels like it's being nice with the other ways, where it's like, please give us an integer, and then you put in a bunch of numbers, and then it's like, okay, I'll take the integers that I asked for, and I guess I'll hold on to these letters you gave me too. I don't know what I do with this, but maybe I can use it later. Whereas if it asks for an integer and then it's like, here's some letters, it's like, whoa, no, I'm asking for integers, hello, right? That's how I'm imagining it. All right, +5, 3 spaces, that would be a 0, because -5 is an integer, but +5 is not anything. That's a buff. 5 is printed. Whoa, we're learning so much. The leading white space is skipped. Plus is a valid symbol at the start. I didn't think it would be valid. That's interesting. Valid symbol at the start of a number, just as a minus sign would be. So it is extracted. The 5 is also extracted. I guess technically +5 is like +5. So it's like, I guess, yeah, that's not the integer I needed. Sure. That was really weird that you specified it like that, but I just needed the 5, right? 5B6. I think, okay, it will pull the 5. It will result 5, and then the B6 will go into the buffer. Remains for future extraction attempt. Love it. Question 2. Oh my god, that was question 1. Whew. Ask the user to enter 3 values. The numbers should then print these values. Add an appropriate comment above function main. What? Program should match the following output when run with input values 4, 5, and 6. Enter 3 numbers 4, 5, 6. What am I saying? What are we doing? What's the question? What are we asking? What? Question 2. Ask the user to enter 3 values. The program should then print these values. Add an appropriate comment above function main. So what would the comment be for this code? Or wait. Or is it asking me to write this? Yeah? Is that should I do that? Is that what we're doing? I'm going to, I guess. Wait, hold on a second. Okay. Question 2. Ask the user. Like it's asking me to ask them. For 3, enter 3 values. Right. Enter 3 values. For 3 numbers. And then we can do program should then print these values. Oh, he wants to say enter 3 numbers. Okay, so I want to do shit. X. C. Define variable X to hold user input. Hello. And then, okay, so these are now initialized, right? And then we will character input. I'm trying to remember. Was it like something like that? I gotta go check before I run this, but or maybe we run it and see what it yells at us about. I feel like that. It's not saying nothing, right? Oh wait, maybe it is upset. Change not saved. I'm gonna save it. It's okay. Oh, it's not upset at all. Did I just get that? Get numbers from keyboard and store it in variable X, Y. Shit. See. Okay, I hit the insert button and I got confused. There we go. X, Y, and Z. You entered. Oh gosh. Okay, this is character inputted it, and then we outputted it. So we're gonna. Are we outputting a new line as well? Why? See? Is that right? Changes are saved. It's not yelling me about nothing. I have to compile it. Control F7. Build. 1 succeeded, 0 failed. Control F5. Enter 3 numbers. 1, 2, 3. You entered 1, 2, 3. Okay, we did it. Wait, it does look different. Oh, because I need to do output that, and then the commas is what I'm thinking about. I'm like, it's just like 1, 2, 3, and we want it to be 4, 5. Okay. Add an appropriate comment above function main. I don't know. Program will ask for three numbers and output it to the console. Yep. Okay. Now, we want it to have commas. I do. I feel like I need to use these single quotes. So I need to, like, maybe output X and then I think I want to this might be so silly. Oh, it's not upset? Hang on. X. Oh, wait. I want to do regular. Or like this. Don't be mad. Shh. It's okay. Wait, what did I do? What? What's happening? My code! No! Okay. I wanted to double. Don't be sad. Hang on. Wait. Oh, wait. X. Space. And then missing closing quote. Yeah, I'm confused. You entered. Boop, 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 boop. Oh, it's you. You. And then boop, 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 boop. Yep, 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 yep. And then X, comma, Y, comma, and space that. And then we can choop, choop. Hang on, hang on, hang on. Choop. See, I think that's the problem I'm having. It's inserting. I'm doing this like quote and then it's like adding extra ones and then I'm confused. I don't want it to do that. Is this upsetting? Is this good? Save it. Are you happy? That feels a little messy. Feels there's probably a way easier to do that, but just from what I've been shown, we're gonna control F7. Happy. Control F5. Enter 3 numbers. 1 space 2 space 3. You entered 1, 2, and 3. And wait, let's do it again because we'll get it to look wait, F7. Oops, F5. We'll get it to look exactly like this because it'd be 4, 5, and 6. Enter 3 numbers. 4. Whoops. 5, 6. That looks just like the input here.
Well done.
You entered 4, 5, and 6. Period. All right, we did it. So even if the answer is different, we still did it. With also no errors, no problems. Wow. Show hint. Comments above a function should describe what the function does. Whoops, what did I say? Yeah, that's what it will do. It will ask and it will output. Yes, I did it. Make sure you're double quoting your output, and I did it. Show solution. Is this almost exactly what I did? Hang on, hang on. Ask the user to enter 3 values and print it as a sentence. Hang on, enter 3 numbers. Int y, z, x, y, z. Oh my goodness. I was like, there must be a better way, but this is the way. This is the way. Oh my god, I literally did it perfect. Oh my god. The only thing I didn't do perfect was the comments. I have more comments. That's it. The code is exactly the same. Oh my god. We did it. Note that period new line must be double quoted since we're outputting more than one character. Yes. Yes. I noted it. Where's noted? There she is. Noted. Okay, we're gonna do the next lesson for sure. That was so fun. But I'm going to take a break because wow, that was a lot. But I feel, especially after that, I'm like, oh my god, like I just retained like a lot of stuff. Okay, I love it. So let's see, 1.6. Uninitialized variables and undefined behavior. Don't be undefining your behavior. Okay. It was. Oh my god, that was so fun. All right, I will be back. I'm gonna walk around. I don't know, stretch my legs. Reflect. I'm having a great time. All right. See you.
Reflect on your win.
we're back. Let's just get right back into it, right? All right. Uninitialized variables. Who needs testing? It works. Toasty just has a red alert now. I don't know. That's all we know. Season 2. Oh my goodness. Can we talk about these emotes real quick? Real quick. Artiste. He's an artiste. We've also
Don't
got
forget the sunglasses.
buffering. Oh my god. We're literally learning about buffering. Don't forget the sunglasses. Whoops. We're here. And then we've got SIP has been updated. Hang on. We're gonna do a little emote showcase because I can. SIP got an upgrade. Looks a little more how I actually originally imagined it. I don't know what was happening when I first was drawing it. I remember, I think we did it on stream and I was like, I don't know, it just isn't, it's not looking right. The popcorn, incredible. I feel like I maybe want to add a few more frames to it, but I kind of like how quick it is. Like, I was wanting that, but then no. It's just the artist's, challenge is never good enough. But this is a top one for me. I love it so much. Also, I did LOL because that's my go-to laugh, as far as like lol or whatever. Raffle. Oh, and then lurk. That's what I want to talk about. Lurk. I feel like so many lurk emotes are like just peeking around a corner. Lurk to me is like such a dark, like sinister word. Like I'm lurking in the shadows, Especially like I'm watching your stream from the shadows, like I'm lurking. That's how I see it. And so especially we have like such a horror lean to the channel. It's like that'll be like the horror emote is lurk. It was so dark feeling. No, because it's like I'm watching. Dark towards the lag. And you're not lurking because you're talking. You're talking a lot. We've got updated stop sign. Just stop. Tannabo stop. I didn't like with the original. I had it kind of like there was the mustache, which I do like the mustache, but I had the mustache with the sunglasses, which that was the sunglasses originally. And then like that brim of the hat, it was like all the same color. I could have maybe, I don't know. When I was working on it, I was just like, the mustache isn't really needed. It kind of confuses things when it's like, it just needs to be stopped. Stop right there. And then we love typees. That is based off of People Chat. Also, Tannabo Z. I love that one because he is ready to, what is the word? Retire for the evening, like that is the retiring for the evening emote, Obviously noted that this is the last one I made. I put it off so long because I was like, this is gonna take forever, and it didn't. And I love him so much. He has my glasses. He's just so cute. He's like so smart and like just wants to learn. We have a cry. Just, I felt that it's necessary.
I am retiring for the evening. Pleasant dreams.
You can do emotes in the TTS. Oh, but he will
They
say
ask
it.
you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
They would never understand. And then I'm like, do I show these off? I don't really, I'm like, these are like the higher tier. This is, I believe, the tier 3 sub emote, because I was like, if you're gonna go tier 3, then you're hard you picked hard mode, you know? So this is hard mode Heather. She's got the katana, she's ready to fight God. She's great. Maddie. I'm not used to Maddie moving that quick. Like I'm scared. 60 frames per second, you know. And then we've got Tannabo Trash, but you got the little banana peel for Tana Banana. A slow zoom. Yeah. I love them all. Honestly, like I just like keep looking at them like, oh my gosh. Okay. Maggie, what are you doing? Oh my goodness. Are you a baby? What? Oh my gosh, she wants to eat the earbud. You want to say hello? Oh my goodness. What's wrong?
Maddie, you are the best.
What? Do you need something? I don't know, she's upset. She seems sad. You okay? Hello? Ah! Naraku! Damn you! Oh my gosh. Hello! You just missed the emote showcase. But now we have the Maddie showcase. Oh my gosh. I gotta show it off a little more. Oh my god. This is one purebred Maddie. She's got the underbite and everything, so you know she's quality. I don't know why she's sad. What is wrong? What? Are you gonna throw up? Do you feel sicky? Do you feel sicky? What? I have to like stop the stream. Not actually, but like we have to put the stream on pause. This. What? What do you mean? Wanna lie down? Lie down. Look at that down. Oh, what is he doing? She's both lovies. I don't think so. Are you okay? Happy? What's wrong? You wanna lie down? Lie down. Stretch. Good stretch. Here you go. Got stringies? Here you go. Okay. She's got her strings. She's happy now. Hang on. Can you see the string? No. There's like string antenna on the short scramp. She likes messing with them. Okay, I think she's better. I don't know what that was. She got all lovey out of nowhere. She didn't know everyone was watching. She gets all soft with me, but only like when we're alone. Oh my goodness. Okay, oh my god, there's all this chat. What the heck? full of modsters. We love it. Oh my goodness. Look at you. Hey, baby. If you you see me like look this way or whatever, I've completely. Who are you? Are you? I've completely 2 hours in. It's been great actually. We just wrote code on our own and the answer was exactly what they were asking for. Like it was like saying like write a program that does this. And I was like, okay, and then I wrote it exactly the way the answer was. It was incredible. Anyways, I flipped. You could see like text is now proper, like not backwards. I now have everything on this monitor and my microphone is coming out of over here by my window instead of over here by my computer. I don't know if you guys remember like in the mirror here. I'm rambling now, but in the mirror here, there used to be the microphone and now it's all gone. There's all this room here. And now I'm facing this way, but so I'm so used to like in stream it being flipped. So then I see her over there. So I was like, oh, she's not there. Where'd she go? Are you sleepy? I don't know what that was. That was so cute. I'm in. All right. We are little programmers. Let's do it. Emote showcase is over. Here we go. 1.6. Uninitialized variables and undefined behavior. Uninitialized variables. Unlike some programming languages, C and C++ does not automatically initialize most variables to a given value, such as 0. When a variable that is not initialized is given a memory address to use to store data, the default value of that variable is whatever garbage value happens to already be in that memory address. Okay. Is that maybe what people mean about it being funny with the memory allocation? A variable that has not been given a known value through initialization or assignment is called an uninitialized variable. So it's like the X curly brace with nothing in it is an uninitialized variable, right? Wait. Something that hasn't been like pulled out of memory. Isn't that so perfect? I was like, I made it. I was like, that's for sure gonna be needed. So it's saying that like it'll pull whatever garbage value, but if there is not even a garbage value to put into it and it's just a variable with nothing, then it's an uninitialized variable, right? Right. Nomenclature. Many readers expect the terms initialized and uninitialized to be strict opposites, but they aren't quite, okay? In common language, initialized means the object was provided with an initial value at the point of definition. Uninitialized means the object has not been given a known value yet, through any means, including assignment. Therefore, an object that is not initialized but is then assigned a value is no longer uninitialized because it has been given a known value. Right? I think I get it. I'm pretty sure. To recap, initialized, the object is given a known value at the point of definition. So like int x curly brace 5. X is 5, right? That's an initialized variable. Assignment. The object is given a known value beyond the point of definition. What? Oh, assignment. Okay, so that's like here where we've asked the user for information, so it's given an assignment later. And then uninitialized, the object has not been given a known value yet. So it would be like the X curly brace without the input later. So it's just never given a value. It's just empty, stays empty. Okay. But could be filled later if we wanted to. Yes. Relatedly, consider this variable definition, int x. Okay. In lesson 1.4, variable assignment and initialization, that's the one where my brain like went to mush. So it's like, we're probably, now that we're reading through it more, we'll start like, oh, that's what that meant. That's what the hell they were talking about. We noted that when no initializer is provided, the variable is default initialized. The default 0, right? No, wait. C++ doesn't have a default. Wait, no, wait. I'm confused. Let me read. We noted that when no initializer is provided, the variable is default initialized. In most cases, such as this one, default initialization performs no actual initialization. Thus, we'd say X is uninitialized. So default initialization is an uninitialized thing. Variable. Right? We're focused on the outcome. The object has not been given a known value, not the process. Okay. So yeah, I believe what it had said earlier in like earlier lessons was like, in some programs, the default initializer is 0, but not in C++. It stays uninitialized, it stays empty. The default initialization is being uninitialized. I believe that feels true. Yeah. As an aside, this lack of initialization is a performance optimization inherited from C, back when computers were slow. Ooh. Imagine a case where you were going to read in 100,000 values from a file. In such case, you might create 100,000 variables, then fill them with data from the file. C++ initialized all those variables with default values upon creation. This would result in 100,000 initializations, which would be slow, and for little benefit since you're overwriting those values anyways. So for now, you should always initialize your variables because the cost of doing so is minuscule compared to the benefit. Once you are more comfortable with the language, there may be certain areas where you omit the initialization for optimization purposes. But this should always be done selectively and intentionally. Okay. Mm-hmm. Sorry. I'm like relating this to fucking therapy somehow. Like, it's like the choices you make. Like, as long as you're like really thinking them out and are intentional with them, and you're not like letting your emotions guide you, then like it's probably the right decision. Like, you can let your emotions, you know, be into it, but like involved, but like not let it be the deciding factor. You know what I mean? Am I ranting? Am I making any sense? Intentionality in decisions is important. I think is the point. All right. Using the values of uninitialized variables can lead to unexpected results. Consider the following short program. Okay, I'll consider it. Define an integer variable named x. I know, that's literally. Hang on. Sorry. Also, Bearcat, I need to show you. This is tier 3 hard mode. Heather. She's got the katana. She's incredible. Okay. Okay. Integer x. This variable is uninitialized because we haven't given it a value. Print the value of x to the screen. Character output, x, new line. Who knows what we'll get because x is uninitialized. I guess we'd get... We would... Answer may or may not change every time you run the program. I want to try that. Oh, no, we need the IO stream. She needs to be there too. 7. Oh, but it doesn't like the uninitialized. Well, deal with it. There were errors. Would you like to continue and run the last successful build? The last successful build? No. Hang on. Let me... Hang on. I'll just say yes, I guess. No, it's doing the last 3 numbers. Don't do that. Debug. Start without debugging. And this doesn't like that. It's like, well, I'm debugging anyways. Build. Build. I may not be able to then? What is it saying? I'm like, I can't really even get it to... It's like, fix it. Please just fix it. Could you just... Anyway. Very upset. One morning, using uninitialized memory. I don't care about warning, but an error. It's upset about the error. Uninitialized local variable x. Well, so on line 9, here it's upset. It's uninitialized here, but it's upset here because it's trying to pull it. So here's actually where the problem is, but this is where it got stuck. What? What do I just tell it? Just do it. Compile. Control. Control F, compile. What's the difference between compile and build? Just someone tell me, please. Build it. Build it, damn it. And then run it, damn it. Start. Just do it. Yes. Do it. Damn it. No. You entered 0, 0, and 0, bitch. Well, I did not see that happening, actually. Try to turn off SDL checks and properties. Is that actually something helpful? Just, oh my gosh, thank you. Hang on. General. Family file. Or edit. Son of a bitch. Hang on. We'll figure it out. STL check. Yes, welcome to the stream. Oh my goodness. Thank you. Let's look it up real quick. Visual. STL. The menu, tools, and then property. Tools. Whoa. Options. Why would it be under tools? That's crazy. Okay. General. Oh my goodness. Hang on. I'm in general. I don't see anything about SDL checks, but I will search. I don't see anything. We have made it to the options. I know. Give me one moment. Options. Shoo. There she is. Yeah, we're in general, but it's environment. So it might be projects and solutions general. Show error list. Store solution. I feel like this is a correct area. Will it just like really, it will like not run? Yeah. Will it just like not run if there's an error? Like it just doesn't, it don't like that. Debugging? General? Yeah. Configuration properties. Was it okay? Open the project's property pages. Project. Don't think this is the right window. Project. Oh. Set the configuration properties. C++ general property page. What? How do I get to property pages? Configure startup projects. Property pages? Ah! Configuration properties. Ah! Oh my god, we're doing it. C++, huh? What? C++ general. Hello? They've lost me now. Configuration manager, maybe. Choose debug and configuration. For here, hit debug. Is that what you mean? Also, oh my gosh, I just realized this is like crazy. On top if it allows. Oh my goodness, hello. Hang on, let me do some adjusting around that. Oh, okay. Make it a little smaller. Okay. Okay. So, was that all I needed to set it to debug? Like, release is like, hey, we're trying to release it, so you can't have errors if you're going to release it. But a debug, it doesn't matter if we're running it, right? Right? I hit apply. Yeah, I don't know. Debug properties. Ah, is this maybe where it's supposed to be? Property pages. This feels better. Oh, but what was it? Configuration properties. This one. General. Oh. Set the SDL checks. SDL checks. See, but if Oh, okay, we were in the wrong place before when I searched SDL. Set to no. Inherit from parent project. No. Love it. Okay. So. Start without debugging. Wait, should I have compiled it again?
Woot.
It is so upset. Yeah, it still doesn't want to. Yeah. Some compilers, such as Visual Studio, will initialize the contents of memory to some preset value when you're using a debug build configuration. This will not happen when you're using a release build configuration. Therefore, if you want to run the above program yourself, make sure you're using a release build configuration. What? For a reminder on how to do that. Well, let's get the reminder. A build configuration. Damn it! That's what happens when you take too long, like a year. It's been a year since we read this. Okay. A build configuration, also called a build target, is a collection of project settings that determines how your IDE will build your project. Your build configuration typically includes things like what the executable will be named, what directories the IDE will look in for other code and library files, whether to keep or strip out debugging information, how much to have the compiler optimize your program, etc. Generally, you'll want to leave these settings at their default values unless you have a specific reason to change something. Let's see, the debug configuration. Show the bugs. Just show me the bugs. I want it to break. Okay. Although you can create your own custom build configurations, you really have a reason to, unless you want to compare two builds. Debug. Wait. It is in debug mode. Okay, wait. So should it be in this mode? Is that what it's saying? I feel like it should be opposite though. I should want it in debug mode. See, that's not right either. This isn't right. What if you had enabled treat warnings on error? I believe the tutorial did say like treat warnings as errors to like keep your code clean. I didn't mind that, but now I'm like, well, I want to see it be messy. So like maybe that's the setting that's doing it. Where was I? Debug options, that's all it was. Right? Wait, where am I now? I'm lost again. No, it wasn't debugging options. It was Hello World debug properties. The properties pages. C++, general, and then warning level 4. Treat warnings as errors. No. Warning. How strict do you want it to be about error codes? Enable all warnings. Turn off all warnings. Let's go. All right. It doesn't even know what to do. It's like, what are you? Okay. There you go. It's great. It's great. Go. Ah! Okay. It did it though. It did it. Okay. We figured it out. Thank you. Thank you so much.
Or you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
Yeah, exactly. It's like I need to see it break to like understand how to put it back together. Okay. Debugger. Runtime check failure. The variable X is being used without being initialized. Press retry to debug the application. Wow. Oh my goodness. See, it's not saying what this was saying, that like, oh, it'll give you this, but this is still interesting. Like, it is literally saying like, look, it's not initialized, which is what the code is. I'm just interesting. It's interesting that it's like so upset about it, but here in the lesson, it's like, it doesn't really, it can run. I don't know. But that's what the whole reason I did this was, because I was like, oh, every time you run it, you'll get a different value. I was like, oh, that sounds like fun. Let's see what we get. And then it just like didn't want to go. So now I feel like this has just lied to me. Because it says that some unused memory will be assigned to X. I assume because there isn't any unused memory is why it's like, I don't know what to do. It will then send the value residing in that memory location to character output, which will then print the value interpreted as an integer. Oh. That makes sense, because honestly, it pulling just random memory numbers, like that sounds more broken than it saying like, hey, this is uninitialized. That is a really good point. Okay, then I won't linger on it too much, but that was actually really fun to like, I'm like, please just go. And I'm like, we're getting used to the IDE and everything. Okay. Some compilers, Visual Studio, will initialize the contents. Right. But it will not anymore, probably. Okay. Most modern compilers will attempt to detect if a variable is being used without being given a value. If they're able to detect this, they will generally issue a compile time error or warning or error. For example, compiling the above program on Visual Studio produced the following warning. Uninitialized local variable X used. Yeah, it did do that. If your compiler won't let you compile and run the above program because it treats the issue as an error, here's a possible solution to get around this issue. Do nothing. Same. Just quit. Some compilers will just do the tutorial saying, but yeah. I kind of like, I guess that better, it's better that it's strict, you know? I don't know. All right, do nothing. Don't worry about what and is for now. We're just using it to trick the compiler into thinking variable X is used. Gotcha. I was thinking about putting, but that, it would have been the exact same thing. I was thinking about putting an empty curly brace next to the X. Like, look, like it's just gonna get information later. But I think it still would have been like, no, there's nothing there. So what do you want me to do? Okay. Uninitialized. Do nothing with the variable. Make the compiler think we're assigning a value to this variable. Okay. character output, X. Using uninitialized variables is one of the most common mistakes that novice programmers make, and unfortunately, it can also be one of the most challenging to debug, because the program may run fine anyway if the uninitialized variable happened to get assigned to a spot of memory that has a reasonable value in it, like 0. It should work, yeah. Oh, let me switch the settings back real quick, because I did like that option. Yes, and then it was 4. Choo-choo. And then yes. Are SDL checks just like extra, like, hey, like, you maybe would like that, it, like, or like, that's better grammar if you did it like this, or like quality of life suggestions or something? Like, what is that? Extra security relevant warnings as errors. So maybe stuff that are like vulnerabilities or something. Okay, no errors. And we got our random number. Oh my gosh. I see. You were like, run that. I was like, okay, that'll give us a random number that we were wanting. Oh. Simplifies the code for security checks. Okay, let me run that again. No, it's the same. ¿Por qué? I wonder if it's just like that number. I'm like trying to figure out how to explain this. My like puddle brain. That like number is memory of whatever the do nothing does. Like, does that make sense? So it's like the do nothing is that variable? No? I don't know. Using uninitialized variables is one of the most common mistakes that novice programmers make, and unfortunately, it can also be one of the most challenging to debug. I already read this. Whoops. Wait, what? Because the program may run fine. Yeah. Okay, I did read that. This is the primary reason for the always initialize your variables best practice. Because if something's uninitialized, you assumed you'd be filling it in later, but then you didn't. If you initialized it, at least the code will not break. Debug does initialize, that's why you get that number. If you build in release mode, it may show another number. Oh, to debug. Okay. You were so helpful, oh my goodness. It's always the same still. It's so interesting. Wait. For example, if you run the program in Visual Studio debug configuration, it'll consistently print that number because that's the value interpreted as an integer. That Visual Studio initializes memory in debug configurations. So it will, because it's Visual Studio, will always be that number. Okay, we figured it out. I feel like every time we run into like I don't understand, we figured it out. Everything we didn't understand today, we figured out. Okay. Undefined behavior. Using the value from an uninitialized variable is our first example of undefined behavior. Undefined behavior, often abbreviated UB, is the result of executing code whose behavior is not well defined by the C++ language. In this case, the C++ language doesn't have any rules determining what happens if you use the value of a variable that has not been given a known value. Consequently, if you actually do this, undefined behavior will result. Code implementing undefined behavior may exhibit any of the following symptoms. Program produces different results every time it is run. Your program consistently produces the same incorrect result. Your program behaves inconsistently, sometimes produces the correct result, sometimes not. God, I couldn't imagine how that'd be written that it would do that. Your program seems like it's working, but produces incorrect results later in the program. Your program crashes either immediately or later. Your program works on some compilers, but not others. Your program works until you change some other seemingly unrelated code. Or your code may actually produce the correct behavior anyway. Oh, like you want it to do something wrong, but then it'll do what it's supposed to, and it's like, no. Like, author's note. Undefined behavior is like a box of chocolates. You never know what you're going to get. Exactly. C++ contains many cases that can result in undefined behavior if you're not careful. We'll point these out in future lessons whenever we encounter them. Take note of where these cases are and make sure you avoid them. Rule: take care to avoid all situations that result in undefined behavior, such as using uninitialized variables. Got you. Uninitialized variables cause undefined behavior of it crashing and being upset over the undefined variable. Author's note. One of the most common types of comment we get from readers says, "You said I couldn't do X, but I did it anyway and my program works. Why?" There are two common answers. The most common answer is that your program is actually exhibiting undefined behavior, but that undefined behavior just happens to be producing the result you wanted anyway, for now. Tomorrow, or on another compiler machine, it might not. Alternatively, sometimes compiler authors take liberties with the language requirements when those requirements may be more restrictive than needed. For example, the standard may say, you must do X before Y, but a compiler author may feel that's unnecessary and make Y work even if you don't do X first. This shouldn't affect the operation of correctly written programs, but may cause incorrectly written programs to work anyways. So an alternate answer to the above question is that your compiler may be simply not following the standard. It happens. You can avoid much of this by making sure you've turned compiler extensions off as described in lesson 0.10, configuring your compiler extensions. Okay. Implementation defined behavior and unspecified behavior. A specific compiler and the associated standard library it comes with are called an implementation, as these are what actually implements the C++ language. In some cases, the C++ language standard allows the implementation to determine how some aspects of the language will behave, so that the compiler can choose a behavior that is efficient for a given platform. Behavior that is defined by the implementation is called implementation but defined behavior. Implementation defined behavior must be documented and consistent for a given implementation. Let's look at a simple example of implementation defined behavior. Hydrate. Oh my gosh. This is not hydrate. I think it is hydrate. I mean, it's quite a bit of water. Maybe. What's the first ingredient? The first ingredient is premium brewed green tea using filtered water. That sounds like water, right? Okay. Thank you so much for your help, honestly. If you want to follow, the whole point of the stream is I need help. Thank you. If you don't want to follow, also, just thank you for your presence. It's been wonderful. I was stuck and then now I'm unstuck. Excuse me. All right. Let's do this. This is a simple example of implementation defined behavior. Hang on. Character output. Size of integer. New line. Print how many bytes of memory an integer value takes. Character output. On most platforms, this will produce 4, but others it may produce 2. What? Let's find it. Four. We got a 4. I felt like that was like okay, what do we got? Did we get the 4 or the 2? We got a 4.
What are you talking about?
I don't know. Gambling, I don't know. We'll discuss size of in lesson 4.3, object sizes and the size of operator. Okay. Oh my god, it's almost midnight. All right. Well, oh, yeah, let's finish this and then we'll rate out because I have a bedtime. This has been really fun, actually. Oh my gosh. I was like, we should do another one. And I was like, oh, it's late. Look at Maddie. She's ready for bed. Oh, fuck. You see? I'm like, I'm not used to it. Hello. Are you a baby? No. Oh my gosh. The angel. Okay. Unspecified behavior. Wait, we didn't run this yet. Did we? Oh. 5. Oh yeah, we got 4. Whoops. We were reading. Unspecified behavior is almost identical to implementation defined behavior in that the behavior is left up to the implementation to define. But the implementation is not required to document the behavior. What? Behavior is left up to the implementation to define. Implementation is not required to document the behavior. We generally want to avoid implementation defined and unspecified behavior, as it means our program may not work as expected if compiled on a different compiler, or even on the same compiler if we change the project settings that affect how the implementation behaves. Best practice, avoid implementation defined and unspecified behavior whenever possible. I don't know what that means, so I don't know how to avoid it. I kind of know. I'm like, I feel like I missed one paragraph. Like I didn't absorb one paragraph, and now I'm like, what? Using this was the one paragraph. Using the value from an uninitialized variable is our first example of undefined behavior. Okay. Behavior is not well defined. In this case, C++ language doesn't have any rules determining what happens if you use a value of a variable that has. See, now I think now it has a rule that it's like, no. If it happens if you use the value of a variable that has not been given a known value. Consequently, if you actually do this, undefined behavior will result. Code implementing undefined behavior. Okay. I understand a little more. Implementation, I think, is where I lost it. Specific compiler and the associated standard library. Compiler and the library are called an implementation, as these are what actually implements the C++ language. Some cases, the C++ language standard allows the implementation to determine how some aspects of the language will behave. Implementation defined behavior. We don't like that this gives us different answers. Well, why is it doing that? Yeah, maybe it's time to end because I'm getting sleepy. I'm like, what? Implementation is not required to document the behavior. We generally want to avoid implementation defined and unspecified behavior, as it means our program may not work as expected. Compiled on a different compiler. Okay. We'll figure. Though it's like when they bring it up again, they'll be like, "Remember we said in this section, don't do that." Yes, I set everything back to how it was. She's all good. Related content. We show examples of unspecified behavior in lesson 6.1. Okay. It's honestly so cute. What is an uninitialized variable? Why should you avoid using them? It is a variable that hasn't been given a value. It doesn't know what it is. Has nothing to do. Doesn't know why it exists. You should avoid using them because compilers don't like not knowing what to do with nothing. Right? An uninitialized variable is a variable that has not been given a value by the program, generally through initialization or assignment. Using the value stored in an uninitialized variable will result in undefined behavior. It don't like it. Question 2. What is undefined behavior? And what can happen if you do something that exhibits undefined behavior? What can happen? A lot of stuff. Lurk real quick. I'm about to raid out. Where are you going? Fine. You can lurk the raid. What is undefined behavior? It is things that the program will do that you haven't asked it to do. You know, like it's giving you different answers, or it's like not running, or it's crashing. It's giving you the right answer sometimes, not others. And what can happen? What can happen if you do something? I don't know. What can happen? That's just such a... I feel like I'm too autistic right here. I'm like, what can happen? Anything can happen. I'm like, it could crash. I don't know. Like, what? Undefined behavior is the result of executing code whose behavior is not well defined by the language. Behavior is not well defined by the language. The result can be almost anything, including something that behaves correctly. Okay, I did say that. Even if it's doing it right. Okay, so next time we will start up on... Oh, hello. No dark mode. We will start up with 1.7. Keywords and naming identifiers. Okay. We will worry about this next week. Next Tuesday. I was thinking maybe about I can't see. I can see now. Well, I can't see. It's bright. Now it's clear. Okay. Yeah, I had been thinking about like doing some lessons like at the end of other streams and stuff, but I'm really wanting, especially now that I have all of the VODs on YouTube, I want to have like a nice big playlist of all of the lessons. So I do want to make sure that we just do these on Tuesday. We have the nice long streams. People who maybe want to just hear me reading through this, struggling through this, can watch it all the way through. How many lessons are there? Because we're getting like 2 done a stream. I kind of thought like, oh, we'll get like this whole 1 chapter done, and it's like we're getting 2 sections done. And like we could do a whole first chapter, and I'm like, holy shit, no. Wow, because yeah, it'll start getting longer too. More things that need to be. Oh, hello, cheap views. Stream boo. Wow. Remove the space, so because like you shouldn't be posting that, right? Is that maybe? And there we go. I was like, what's going on? Okay. Okay. It goes all the way, because we're gonna read through all this. Like, I don't care. I'm gonna be the tryhard like that. The end? Question mark. Whoa. Okay. Oh, there's like updates. So like once we've learned stuff, then they'll be like, so this is new. Okay. Oh my god. Okay. There are 20. There's more. And maybe these will be like quicker. They're like the ending stuff, but the last chapter is chapter 28. 28. It's been three streams so far. And we have not finished chapter 1. I don't think that's terrible. A terrible rate. I would like to maybe we'll do more. I'll probably do like some Saturday streams and try to do like a all day. We'll have a lot of breaks, but like just read through, take a whole Saturday, you know? That's true. We won't be struggling as much. Like, what's debug? Like, huh? That's true. I didn't really think of that. That it'll like just start to get like a new tool. Like, oh, it's a new thing we can try. Like, you're so right. Okay, let's figure out rating. Right? I don't really remember how. We'll figure it out. I always do. Please don't make a sound. Okay. Yeah. I think we gotta go with tried and true. Nidster. What? Here we go.
Bad thought.
Okay. I need to remember. Hang on. Is it crap? I'm literally like, it's not exclamation mark, right? It's like, what is the freaking? I'll look it up. We're getting it back, okay? // Okay. We did it. Does this work? It does. That's our raid message. Thank you for being here.
Oh, no, man.
We did it. And also, probably should have mentioned this earlier, but I will be back tomorrow, hopefully. I'm wanting to play. It's a surprise. A surprise. It's retro. Okay? It'll be fun. I'm going, yeah, surprise? Not for you, you know. I know, oh my god. Alright, I'm gonna start this raid. There's the raid message. Okay. I'm gonna send you guys out. Thank you for being here. I kind of lingered a little bit, but I'm very excited, very happy to be here, and I'll see you guys later. Bye.